Hello friends, welcome to JavaEE EJB JPA tutorial. In this video, we are going to see the basics of one-to-one relation. And here we are starting a new subseries. And in this subseries, we will learn the one-to-one relation with an example. So these are all the prerequisites. So far we have six subseries, and in subseries 3 we created our first JPA project, and we are still using that same project. So if you want to know how to create a JPA project, you should watch this subseries 3. Then in subseries 4 we started implementing the entities. Then in subseries 5 we learned how to use the entity manager merge method. Here implementation of entity, in the sense we learned the create, read, update, delete action and how the state change occurs. Then in the previous subseries we introduced JPA and we also learned how to use it. So in subseries 6 we used a simple entity, and here in subseries 7 we will be using a complex entity in the sense entity will have one more entity, so thereby it will define the relation one-to-one. So the code snippets will start with 7.xyz. xyz is 7.1, 7.2, like that. So for each subseries we are not creating a new project and redoing all this stuff which we already did. So it will be a continuing series, and if you have some expertise on JPA, then you can directly watch this video, or if you are seriously learning, then you can start from subseries 3 and start flowing from there. So the project was created in subseries 3 and pieces of code added in these subseries, and in subseries 7 we will learn one-to-one relation, and in the meantime we will add some piece of code. So let us say car is a class in Java and the same car is a DB table. So in plain Java class car, the class car can act as a JPA entity by means of a proper annotation. That means the car entity here, which should have a proper field mapping in the DB table, which we already saw when we created the savings account. So when the field in car in plain Java corresponds to some of the corresponds to a specific field in the DB table, then we can convert that plain Java class into a JPA entity by means of a proper annotation. Here annotation in the sense at table, at column, at ID. So these are all the annotation. Using this annotation we can do the mapping. So these stuffs also we saw in the previous in one of our previous subseries. When we created the savings account entity, that time we mapped that plain Java class with the savings AC DB table. So in plain Java we have a EJB relation which represents inheritance. So ECM means Say for example, a car is a vehicle. So that's the plain English, right? That means we will be having a class called vehicle, and car is derived from that vehicle, or lorry, jeep, whatever you call. Those get derived from vehicle. So here ECA relation is coming into picture. So we can say in plain English language, so here there are two classes in Java. B is a, that means B is derived from A. So A will be the base class and B will be derived from it. So this is simply a ECA relation in plain Java world. Similarly, in plain Java we have has a relation also. So wherever the has a suits, that time we can use the has a relation. Say for example, so this is plain language, car has a door. So here we are not saying car is a door. So we can say car is a vehicle. So A will be vehicle, B will be car, and car is derived from vehicle. But the same car, if you see, car has a door. So here there are two objects. One is a car and another one is a door. And if you mark this as A and door as instance B, then what we have here is a containment. So the class instance A contains instance B, right? So this is A actually. A contains B. A contains object B. Has A has a B. So this is what called a has a relation in plain Java, containment. So now let's go to the DB. In DB, has a can be modeled by a primary and foreign key relation. So now we can think of this as a table. A is a table, then B is also a table. So here we can pick one column. Let's say in table A, this is the ID column, some other field, and in table B there are some other field, and here is some column, let's say BC. So this BC column can act as a foreign key, and this ID column, this will be the P key, and this foreign column will refer the primary key column. So based on the value present, let's say here this is the value, it knows where to point a specific record. Here if you see, the join will be like this, or we can say, so this is the referring candidate, right, in DB table B. So here it will be in reverse in terms of model. B contains A. This one, B, this is foreign key, right? Foreign key referring back a record in the P key table. So that means the record B contains record of A. So here record B has a row in record A by means of foreign key and primary key. So that's what we are saying here. In DB world, the same, this containment or has a can be modeled using primary and foreign key relation. So JPA entity can represent one-to-one relation using this primary foreign key. One-to-one relation can be modeled using has a relation. That means by making use of a containment. So when we talk about JPA, then the Java class template will come into picture, right? So if we want to model this, here it will be in the reverse order, right? We took this one as a primary key. That means so this one as a foreign key. So if we model this in a plain Java class B, or we can say in JPA terms entity B. Entity B means the B will represent this table. Entity B will have containment of entity A, some obj. So we know that, so there will be a entity A also here with some specific field definition, and this will be the B's field definition. And if you see, when we map other column, the B will contain instance of A also. So it is having a containment. So entity B contains entity A. That means entity B has a entity A. So when we do our coding, the entity A will get pointed here and B will point here. Thereby we are establishing a relation. So for a given A, how many instances exist, that defines whether it is one-to-one or one-to-many. In our example, we are going to make one-to-one relation. In this sub-series, we will extend our example to use one-to-one JPA relation. By this time, you will be having an idea of, we already have one entity, that is a savings account. And to define the relation, we may need one more entity, and we will see that soon. When we are going through the sub-series, we will create the new entity here, then we will see how to perform the relation. So the relation has a direction as well. In one-to-one relation, a table column can point to only one row in another table. So here we are talking one-to-one relation, right? That means, let's say there is a table A, table B, and when a row is pointing another row in table B, we call that as a relation. And when that pointing happens or mapping happens for one row in A, there will be definitely only one row in B. So in that case, we will call that as a one-to-one relation. For table A, there is one row, and there will be a corresponding single row in table B. That means it's a one-to-one relation. That's what here we are specifying. For example, the person holding the saving account can live at a specific location. So if we assume a person who is holding the savings account can live in only one location, then we can call that as a one-to-one relation. Or we can take it like this. So in the savings account form, when the person is filling the form, even though he may have 2 or 3 addresses, the requirement states that he should provide only one address location that should be tied to the savings account. So in that case, the model will go as a one-to-one relation. So if there is a saving account, then there will be a mapping address location, and a saving account cannot have multiple address location tied to it. So it ends as a one-to-one relation. Here the direction is from saving account entity to location entity. Say for example, we already have saving account entity, right? So we know we have a savings account entity. We already created as part of our previous sub-series. And this savings account will map to savings AC in the database table, and these fields will map a database column. So we know all this stuff. And if we introduce one more entity called location, the location will have its own attribute. This is one more entity. This entity we will introduce in this sub-series. Here, let's say we have ID again to uniquely identify an entity, then street, city. So you can even add more field that belongs to a location, but for our example we want to take only 2 other field apart from this ID. So this is just an example, so we will just define 2 field. Now here we will have a containment for location. This is the location entity, right? Location, and let's say the field name here is L. And if you see, there is a one-to-one relation, and the location attribute of savings account or the location field of a savings account will point to a specific location of entity. That means at runtime, if you see, if we have a runtime instance for savings account, then there will be only one runtime instance on the location, and using the ID field here, we will be pointing to the location entity. And the direction, if you see, since we have a containment here on a savings account, the direction is from saving account to location entity. So that's the direction here. It's we can call this as a unidirectional. Unidirectional in the sense, if we at runtime, if we have savings account and if we have ID X, and then in the collection of location entity, we can pick a location with the ID X. Thereby we will be establishing a one-to-one relation, and the direction is, if you see here, for a given saving account we can find the location. Since it's unidirectional, for a given location we cannot find any saving account because there is no detail about the savings account here. So that's why we call this as unidirectional. So in DB world, location table will have a primary key and the other have foreign key. So if we model the same, we'll be having a primary key in the location table. Why? Because location is the target here, right? Source is from the saving account. So location will have primary key and other in the sense here savings account will have a foreign key. That means the location containment that we specify here, right, this will be treated as a foreign key, and when a foreign key contains some value here, that value will get pointed by the ID field here. So this will be the primary key. Or the location containment here will point to a location entity by means of the ID. So at runtime, when a specific ID, let's say we have multiple location entity, for example we will have 3 entities for location, and at runtime we have a savings account entity as well. Apart from other field, for location we will be having a ID denoted as a 2. So that means what happens, so the 2 will get loaded from the database and it points to the location entity, and in the database table it will search that, then it will construct it, and it picks this one from the database and establish the relation. So that way, if you see, this is foreign key and this one is the primary key. So we no need to model F key and primary key at the database level, since we are dealing those here in the entity level. So in DB level, you can create a two table without defining any foreign key. Why? Because it is taken care by the JPA entity. So in our subseries here, we need to create entity for location. So we already have the savings account. We need to create an entity for location table for this one. Then set up a relation between savings account and location. So by doing so, we will learn the one-to-one relation and how we can work with two entities, thereby setting up the relation and modeling the database one-to-one relation between two tables. So as already explained, the direction is from saving account to location. So as already told, saving account will have its own field, and this field will map to database. Location, it will have its own field and it will map to a different table in the database. And here we establish a relationship between savings account and location, and in our example we are going to make this as a unidirectional relation. So that means in the underlying database, let's say it is pointed out by the table A and table B. So here by implementing this containment, we are establishing the relation in the database as well. So there is a relation between these two entities, and there are database tables tied to these two entities. When we establish a relationship between one entity to another entity, the corresponding database table will have that same relationship. That means we will be creating a location table also. Savings account already there, but for savings account table we need to add one more field to establish this relation. One can also model bi-directional one-to-one relation. So here itself, let's say there are two tables, table 1, table 2. Let's assume we have some rows here in table 1 and some rows here in table 2. Now we will also assume there is a mapping so in unidirectional, from one table to another table you can move. That means when we know a specific field here, we can pick a record in the table 2. But in case of unidirectional, you can move in both the direction. That means if we know some field here in table 2, we can pick a corresponding record in table 1. If you see here, we are saying we are going to implement our example as a unidirectional. Here we will be having location field. Using that, we can pick some record in the second table. But there is no field related to savings account here. So the moment you introduce savings account and provide proper mapping, I mean the proper relationship attributes, then we can make it as a two-directional. So even though we are not going to implement two-directional, I mean bi-directional in our example, towards the end of this sub-series, we will provide you an idea of how to establish bi-directional relation. Also, we will give an idea of how to traverse in bi-directional relation. Alright, in this sub-series, we will model one-to-one unidirectional. That will give you a good idea of how the relationship between two entities are established, how the data will get persisted between these two tables or in the related table. All those stuff we can learn. So there is no demo in this basics of one-to-one relation video. Thank you for watching. Bye.